All right, so for this problem, we've got an electron of this mass. This is just the mass of an electron. Has an initial speed of, in my case, 3.2 times 10 to the 5th meters per second. It travels in a straight line, and its speed increases to 6.2 times 10 to the 5th meters per second in a distance of 4 centimeters. Note centimeters. Assume its acceleration is constant. And we first want to start off by determining the magnitude of the force exerted on the electron. So to find the force, we can use F equals ma. The force exerted is going to be equal to the mass of the electron times its acceleration. But we don't have its acceleration, so we're going to have to find the acceleration. Let's go about doing that. I'm going to start by writing down the knowns and unknowns. What we know is the initial speeds here and the distance, the initial and final speed and the distance. I'm going to write those down here real quick just so we can see them written out. All right, so here are our knowns and unknowns. We've got the initial and final velocities. We've got the distance is 4 centimeters. And again, so you've got to convert that into meters because that's our standard units. Now there's one equation that relates all of these, one of our kinematics equations, and we can use our kinematics equations because the acceleration is constant. That's a very important distinction in this case. The equation we're going to use here is the one without time in it, which is the v squared equation. Here's the equation. If we solve for the acceleration, we need to first subtract the v naught over to the other side, then divide both sides by 2d. And that's equal to our acceleration. Now, we can go ahead and type this into our calculator to find the acceleration. V squared final, which is going to be 6.2 times 10 to the 5th. And remember, you can use this little letter E to do scientific notation, times 10 to the 5th. And since it's squared, we can use this squared. If you instead do star times and then 10 raised to the caret 5th, you have to make sure you've got parentheses around the whole thing. If you do it this way, it's a shortcut. You don't need parentheses in this case. And then it's going to be 3.2 times 10 to the 5th. That's also squared. And now you can either put parentheses around this and then divide, or what I'm going to do is I'm just going to evaluate that. That tells me this is the numerator, divided by 2, divided by 0.04. And that should be my acceleration. This is my acceleration in this case. So with this acceleration found, all we need to do now is plug that into F equals ma. And we get a pretty small force because the mass is very small. Just going to take this acceleration and multiply by 9.11 times 10 to the negative 31st, which is the mass of the electron. And we get 3.211 times 10 to the minus 18, which is the answer that they said here was the correct answer. So if you put that in the box, hit enter, it should give you the right thing. I mean, you'll have different numbers, so you'll have to go through this calculation on your own. If we go ahead and look at this one, compare the force, this force that we just found, 3.21 times 10 to the minus 18, with the weight of the electron, which we ignored. Well, in this case, we can find the weight of the electron the same way we'd find the weight of any object on Earth, which is going to be that the force of gravity is equal to mg. So that's the mass of the electron times 9.8. And so I'm going to go ahead and pull the calculator back up, just grab this, and multiply by 9.8. And I get 8.9278 times 10 to the minus 30th. This is the force of gravity. That's not the answer for this question, because it doesn't ask what is the weight. It asks how does the weight compare to the force applied. So this is our applied force, this number here, the 3.2, so I can just go ahead and do that, divided by this one, because that's what it says, the force divided by the gravitational force. And I get 3.5969 times 10 to the 11th, which is rounded here to 3 digits, and is the correct answer. So that's how you can do this problem. You'll have to do it differently with your numbers, but good luck with that. Let me know if you've got any questions.